Okay, so today we are going to finish our last final section on logarithms, 4.6, which is solving exponential and logarithmic equations. So our objectives will be able to solve those different types of equations using some of the properties that we've learned. So an exponential equation is when the variable occurs as an exponent. And the general steps to solving one of those is to isolate the exponential term if necessary. Then you want to rewrite each side with the same base. So when we first started solving the logarithms without a calculator in that first part of section 4.4, we were just trying to get the bases the same on each side so that we could just then cancel out those bases. That would be one option, or you can take the log of both sides. That's the other way we're going to do them. And then we're going to solve them. Okay, so for example, if we take a look at this first problem here, if I can somehow rewrite this 9 here as a base of 3, because then I'll have the same base on either side. So we know 9 is really 3 squared, right? So then I can just make this 3 to the 4x power. And on this side, I have 3 to the x minus 6 power. So now once you have the same base on both sides of the equation, you no longer need them because 3 raised to 4x is equal to 3 raised to x minus 6. So that means that those two exponents must be equal to each other. So you're just going to make an equation that says 4x equals x minus 6. And then you would just use your normal linear equation solving strategies from there. So getting all your x's on one side, that gives me 3x equals negative 6. And then trying to get that x alone. So x is going to equal negative 2. So that's pretty much it. Now for number 2, this one's a little bit different because we're like, okay, I have 3 as my base here, which I definitely cannot make smaller because 3 is a prime number. But unfortunately, there's no way for me to rewrite the 14 to make it a base of 3. So in this case, then you do what's called log both sides. So in order to cancel out this base here, 3, you would have to log it with the same base of that number there, which is 3, for them to cancel. And then you'll just be left with your x. But whatever you do to one side of an equation, you have to do to the other. So we're going to log base 3, 14 on the other side. So now this side is just x, and x is going to equal log base 3, 14, which you're going to have to do on your calculator, which is why in the directions it says round to the nearest thousandths if necessary. So when you go to your calculator, if you remember, we have the 2 different options on our calculator. So those of you that have the newer calculators, you're just going to go to the math menu. Typically, the quickest way to get there is just arrow up 2 times to get your log base. You're going to type in log base 3, 14 and hit enter. And there's your answer, 2.402. Now, if you're not so lucky to have one of those new higher tech calculators, then you're going to have to use the change of base formula. So that means you're going to take your common log of this bigger number, which is the 14, and then you're going to divide that by the common log of that little base number there, which is 3, and you'll get the same answer, 2.402. So x will equal 2.402. So that last portion you'll have to do on the calculator if it's not one of the bases that you can change. Okay, so now we're going to get into some where maybe there's a couple things going on. So again, you always want to try to start out by isolating your variable. So for number 3, of course, we're going to subtract that 2 to get it to the other side. So now I have 5 to the x power equals 14. Okay, so first thing I look at is, well, is there any way for me to give those the same base? 5 can't be changed. It's a prime. 14 is not going to have a base of 5. There's nothing for me to change it to. So I'm going to log both sides. So I'm going to log base 5 on the left, and I'm going to log base 5 on the right. That cancels that 5 out there, so I'm just left with x. And then I'm going to just do log base 5, 14 on my calculator. So log base 514, using my log base function there, log base 514. Or if I have to do change of base, I'm going to do log 14 divided by log 5. Either way, you're going to get that same answer, which is 1.6397, which will round up to 1.64. So x equals 1.64. All right, so let's take a look at the next problem, number 4. So again, this one, we have a 10 raised to a power, and over here we have 0.1. Now, we know tens, just moving decimals is basically raising them to exponents. So how can I rewrite this problem so that they have the same base? Well, what is 0.10 really? It's really just 1/10. And we know that 1/10 is really 10 to the -1 power. So if I rewrite it in that form, now I have the same base on both sides of the equal sign. I don't need those bases anymore. I can just solve the equation 3x minus 4 equals -1. So then I add my 4 to the other side, divide by 3, and I get x equals 1. All right, so number 5, before we get too far into this one, I'm going to just start out by trying to get the x by itself. So I'm going to add my 0.4. So I have 0.17x equals 6.4. Now, even if you wanted to, like, let's just say, move the decimals over, you're going to end up with a 17, even if you somehow made that not a decimal anymore, and that's still a prime number, and then you have 64. So nothing really do there. So in this situation, we're going to have to log both sides. So log base 0.17, log base 0.17 on both sides of the equal sign. So now in my calculator, I'll do log base 0.17 times 6.4. So even though they're decimals, you can still put them in. So you would have log of 6.4, oops, divided by the common log of 0.17. Of course, if you have the newer calculator, you can just enter it in with your log base. So I have negative 1.0475, so negative 1.048. Okay, so now let's take a look at number 6. This time I have a base of 2 on the left, which is a prime, so I can't make it any smaller, but 4 could be written as 2 squared. So now, if I can just get rid of my parentheses there, I can cancel out my 2 bases. So this will become 2x minus 2, because I'm multiplying that exponent there. So now I can cancel my bases. I have 3x equals 2x minus 4. Getting all my x's on one side of the equation. That leaves me with x equals -2. All right, number 7, 6. There's no number raised to a power that can give me 6. So I'm just going to leave it. And the same thing for the 21. There's no 6 raised to a power that equals 21. So this is an example where you're going to want to log both sides. And both sides are going to get a log base 6. So I can cancel out that 6. Now this one, instead of me being totally done at this point, I have 2x equals log base 621. So I'm going to have to put that in the calculator, and then I'm going to divide it by the 2. So log base 621, I'm going to use the newer function this time, but you can use change of base if you have an older version of a calculator. So I'm going to put in log base 6, and then we have 21, right? And 1.699, I'm going to round that to 1.7. And then, of course, we're going to divide that by 2. So I can actually just leave my answer in the calculator, divide it by 2, and I get 0.849, which rounds up to 0.85. And there you go. Okay, now number 8, we have a 9 and an 81. So one option is that I could make my 81 into 9 squared, and now my two bases are the same. Another option would be you could make both of them change into bases of 3, but that would just be more work, so I'm not going to do it that way, but should still come out. So this becomes 9 to the 2x minus 14 when I distribute that little 2. And on this side, I have 9 to the 2x. Now, of course, those are going to cancel, so I have 2x minus 14 equals 2x. Now, when I subtract my 2x from both sides, I end up with negative 14 equals 0, which means there is no solution. Okay, a couple more. So again, when there's multiple things going on, you want to start working towards getting the term that has the exponent in it by itself. So the first thing I'm going to do is subtract that 4 over. So it doesn't really affect this term here. So I have negative 6 times 3 to the x plus 4. Over here, I'm going to do 602 divided by 4, which I believe is a decimal, 150.5. Okay, so now this word gets a little interesting because you have negative 6 times 3 raised to this power. So while this part, you can't really do anything with that just now, you can divide both sides by this, negative 6. So then we have 3 raised to the x plus 4 on this side, and 150.5 divided by negative 6 is negative 25.083, repeating. Now, obviously, it's going to be very difficult to change that into a common base of 3. That's literally impossible. So we're going to then log base 3 both sides. That will get rid of the 3. So now we will have x plus 4 on the left-hand side, and then this part we're going to do in the calculator. Now I'm just going to round that. I'm not going to do, all those 3's there. But if I go into my math menu and do my base there, I had log base 3. And then, what was my number? Negative 25.083. Negative 25.083. And that's a non-real answer. Okay, so number 10, I want to shoot for getting this portion here by itself. So we're going to move the 5 over first, just like you would for a normal, equation solving. And that gives us a 4. Then I'm going to multiply both sides by 3 to cancel out this 1/3 here. So that gives me 3 to the 4x minus 1 equals 12. Now 12 cannot be written as 3 to some power, so I'm going to log both sides. Log base 3, log base 3. So now I have 4x minus 1 equals, and log base 3, 12. I can do log 12 divided by log 3 if I'm using change of base, or you could just put it into your calculator using that log base key. So 2.262. 2.262. Now we're going to add 1 to that. So I'm just going to leave my decimal in the calculator and add 1 to it. So plus 1. And 3.262. And then I'm going to divide that by the 4. Again, just leaving it in my calculator to get the most exact answer. and it gives me 0.815. All right, so now we have a couple with the Euler's number involved with them. Okay, so first let's try to focus on getting that alone. So I'm going to add my 4. So I have 3e to the negative x equals 13. And I'm going to divide by my 3. So e to the negative x equals, and 13 over 3. I can leave it as a fraction for now, or you can make it a decimal. But now you need to obviously get rid of this e, and you can't change the 13 over 3 to e raised to a power, so you're going to ln both sides, which remember, that's the same thing as doing a log with a base e, so that will cancel out your e there. So you'll have negative x equals whatever you get on your calculator when you do ln of 13 over 3. So ln of 13 over 3 is 1.466. And of course, if you divide or multiply both sides by a negative to get the x by itself, you'll have negative 1.466. All right, so back to number 12. So this one, I'm going to focus on getting this term alone first. I'm going to subtract the 5. So we have 2/3 e to the 4x equals 3. Now I'm going to multiply both sides by this reciprocal here to get my e in that exponent alone. That gives me 9 over 2. To get rid of the e, I'm going to have to ln both sides. So that leaves me with 4x, and then I'm going to do ln of 9 over 2 on my calculator. So ln 9 over 2, 1.504. And now I'm going to divide that by 4. And I get 0.376. There you go. All right. So now logarithmic equations are those that have a log. So the last set of equations, they were exponential equations, and we use the log sometimes to solve them. But these equations actually are starting out with the log in them. So to solve them, you want to isolate the log term, just like we were isolating the exponential term. And then if each side is a log expression, you're going to give it a base. So when we had the exponential expressions, we logged them to cancel out. But here we're going to, I call it base them, meaning you're going to make the entire log an exponent so that it can cancel out. All right, so the first thing is if you have one on each side like this, similar to when the bases are the same on both sides, you can just go ahead and cancel those out. So because we have an ln on both sides, we no longer need those, just like when you have the same base on both sides, and you just solve the rest of the equation like a linear equation. So I would move all my x's to one side. So that would give me 2x plus 1 equals 5. Subtract the 1. 2x equals 4. Divide by 2. And x equals 2. Now, if I'm to go ahead and do number 2, this one already has this log term, right? So first thing you want to do is basically get rid of this 4. You just want to isolate that log term there. So I'm going to divide by that number out front. So now I have log base 3x equals, and 28 divided by 4 is 7. Now, in order to get this log base 3 to cancel, but just have the x remain, you give the whole thing a base of 3, meaning that this entire thing is now becoming an exponent. If you do that on one side, you have to do it on the other side. So now when you do 3 raised to log base 3x, all of that cancels, and you're just left with x. And on this side, you have 3 to the 7th power. And of course, you could go ahead and do that on your calculator. If it's not too big of a number, 2187. So your answer there would be 2187. 87. Okay, so let's take a look at number 3. So again, this is our log term here that we want to isolate. So the first thing that we're going to do is we're going to get rid of this 1/2 by multiplying both sides by 2. So now I have log base 6, 16x equals 6. Now in this case, I can't get to the x till I remove this log. So I'm going to make the entire thing an exponent by giving it a base of 6. That can cancel. And whatever you do on one side, you have to do on the other. So that now cancels. So I now have 16x equals 6 to the 6th power, which you can do that on your calculator, 6 to the 6th power, which is 46656. And then, of course, you would divide that by that 16 to finish solving for x. So since I already have that on my screen, I'm just going to hit divided by 16. And I get 2916. All right, so number 4, we want to isolate this term here. So first I'm going to subtract my 7, which leaves me a 7. Then I'm going to divide both sides by 2. So I have ln of negative x equals 7 over 2, or 3.5 if you wrote it as a decimal. Now again, to get my ln to cancel, I need to give it a base of whatever the base is here, which is really an e. So both of these are going to become exponents from an e. So now that leaves me with just negative x equals, and I would have to do e raised to 3.5 or 7 over 2 on my calculator. So if I do e raised to 7 over 2, or if you wrote 3.5, it's the same thing, and you get 33.115. And of course, we need to get that negative off the x, so you divide or multiply both sides by a negative, and your answer is negative 33.115. Okay, so now number 5, I'm going to actually go to 6 and I'll go back to 5. So number 6 again is one of those problems where you have 2 logs, but there's one on each side of the problem. So it's actually quite easy because you're just going to cancel them out. So both of these cancel out. You're just left with 11 minus 6x equals 1 minus x. And then you continue to solve from there. So I'm going to just add the 6x to both sides. So I have 11 equals 1 plus 5x. Subtract the 1. Divide by 5. And x equals 2. Now, when we go to the next problem here, it's a little bit different because we have an ln here and here, but number 1, they're on the same side. And if we bring one over, they're not alone on the other side. We have this 1 there. So this is where we want to do our condensing that we had done in the last section. So you want to condense these 2 ln's into 1. That way we can solve it. So since there's a plus sign here, that would mean if we condense them, we're going to multiply those 2 terms there. And of course, if we're multiplying that, it's going to become x squared minus 2x. So that's what we have to do first. We have to do a little bit of that condensing that we did. So now I want to cancel out my ln. So I have to give it a base of e. Same thing on the other side. So now I'm left with x squared minus 2x, and then this is going to be equals just e. And then, of course, you would do x squared minus 2x minus e equals 0. And then I guess you could use quadratic formula to finish solving it, but I will let you stop from there because with the e, it's kind of nasty. But there would be 2 solutions there, most likely, provided your discriminant is positive. Okay, so a couple more. All right, so both of these only have 1 log, so we're just going to isolate that log and then we'll go from there, right? So for this one, we're going to add the 5. So we have 2 ln 3x equals 10. Then we divide by that 2. So ln of 3x equals 5. Then we're going to give each side that base of e to cancel out the ln. So we have 3x equals e to the 5th power. So if I do that on my calculator, e to the 5th power, I'm getting 148.41. And I'm just going to leave that on my screen and divide it by 3 to finish it out. So divide by 3, and I get 49.471. All right. Okay, so this one here, I have to get rid of my 6.5 first, since that's multiplying out front. I'm going to divide that. So now I have log base 5 times 3x equals, and then 20 divided by 6.5. 3.077. So now we want to give both sides a base of 5 to cancel out that log. So I have 3x equals, and then on my calculator, I'm going to do 5 raised to 3.077, which is 141.49. And then that is going to get divided by 3. $47.16. All right. Okay. I think we just have a couple left, right? Okay. All right. So this is actually a 2 over here. So this 2 goes to there, got cut off. Okay. So this is another example where we have to do the condensing for these two because you have 2 logs. So if I were to condense this, I'm going to have 3x times x plus 2. And then I'm going to just kind of combine that a little bit. So it's 3x squared plus 6x. Now, of course, to get rid of my log, I'm going to give it a base of 10 because it's a common log. So now that leaves me with 3x squared plus 6x equals 10. Now that's quadratic. So when you have something quadratic, in order to solve that, you would typically subtract the 10 and equal it to 0. Now at this point, you could try factoring by AC method, or I would just use the graphing calculator since we have it to see if we could find those x-intercepts. So 3x squared plus 6x minus 10. So 3x squared, where are we? Plus 6x minus 10, graph it. You can clearly see it going through the -3, and then it looks like maybe 1 point something. So if I check my table, it's probably not exactly on either of those. So if I wanted to find one of my zeros, if you guys remember back to doing this, I'm going to say it's between 0 and 2. So 0 on the left, 2 on the right, and guess that one's 1.08. And the other solution for x is this one over here. So again, I'm going to go to find my other 0, which is between probably -4 and -2. And that would be -3.08. Now again, if you just look at the graph and you're doing a quiz with multiple choice, you could probably just figure out from there which one it is using your logic. Okay, so this one again, we have 2 logs on the same side. We're going to have to condense them. So we want to make it log base 5, and then we're going to do 5x times x minus 4. Then each side is going to be given a base of 5 so that can cancel. So we're left with 5x squared minus 20x. And over here, 5 squared is 25. which of course you can subtract to the other side. Now this one you can do the same way on the graphing calculator or whatever, but I'm noticing that there is a GCF of 5 here. So if I take out that GCF, I'm left with this here, which is much simpler to just factor. You can always use the graphing calculator though if factoring is not your thing. So the two numbers that multiply to get 5, that subtract to get 4 would be -5 and +1, which would mean your solutions would be +5 and -1. And if you graphed it, they should cross through at those two x-intercepts. All right, and I think we have one more. Okay, so this time we have an ln on one side and we have 2 of them on the other. So those 2 are going to need to be condensed. So this one we're just going to leave the way it is. And this one we're going to condense, but when we condense them, we're going to do it as a quotient. Okay. Now, in order to get rid of the ln's, since there's 1 on each side now, they can just cancel. So we're left with x plus 4, essentially over 1, equals x plus 7 over x plus 3. Now, this would be an example where we had solved these back in chapter 5. So basically, I would probably just cross multiply this. So on one side of my equation, I would have x plus 4 times x plus 3. On the other side, I have x plus 7. So x squared plus 3x plus 4x plus 12. And then I want to combine those like terms there, giving me 7x. Now I'm going to get everything on one side of the equation since it's quadratic. X squared plus 6x plus 5. And of course, then you want to try to factor it if possible, or you can use your graphing calculator to get the two x-intercepts. The two numbers multiply to 5 that add to 6 are 5 and 1. So my solutions here are -5 and -1. And so that's it. So any of the ones that are involving quadratics, I would definitely, try to work it out. You're going to, it's good review for stuff in earlier chapters that you need to know, especially if you're going to be moving on to another math next year. But if there's an E in there, I'm not worried about you doing quadratic formula with that. All right, there's a couple other problems at the end here, but I'm going to skip those for today. So just focus on the solving of equations, do your quizzes for homework. Friday will be just an optional day. I'll post some review material for Monday's quiz. I will probably also post the quiz early. I'll post it Friday, even though it's technically Monday's assignment. That way, if anybody wants to kind of use their flex day Monday instead of Friday, that's completely fine with me. And that's it. Enjoy the rest of your day.